Graph the following: y equals sine x and y equals 2 sine x. Y equals sine x looks like this. If we follow the unit circle values and ask ourselves, what's the sine at 0? We would get 0. So the point 0, 0 is on the graph. What is the sine of pi over 2? That would be 1. What is the sine of pi? That would be 0 again. The sine of 3 pi over 2? That would be negative 1. And then the sine at 2 pi would be back to 0. And this cycle would repeat as we kept going. Likewise, if we go in the negative direction, we will get the following. At negative pi over 2, it's negative 1. At negative pi, it's 0. At negative 3 pi over 2, it is 1. And at negative 2 pi, it's back to 0. So now how does the sine graph compare to 2 times the sine of x? Again, going around the unit circle and finding values of sine. When the sine is 0, the answer would be 0, and 2 times 0 is 0. So 0, 0 is on this graph. However, when we go to pi over 2, the sine at pi over 2 is 1, but with the 2 in front of sine x, we are now multiplying the 1 times 2. And so the value at pi over 2 for this equation is 2. Continuing on, the sine of pi is 0, and 0 times 2 is also 0. At 3 pi over 2, the sine is negative 1, but again, multiplying by 2, we get negative 2, and then back to 2 pi, where we are at 0 again, and again, 2 times 0 is 0. With this graph, this is the cycle that will repeat. In looking at the periods of each graph, we can see that each one has a period of 2 pi, where the period stands for one complete cycle before it repeats again. However, what was different was the amplitude. On the y equals sine x graph, the amplitude is 1. We go up 1 and down 1 as we move across the graph. For the sine y equals 2 sine x, the amplitude is 2. We go up 2 and down 2 as we move along the graph.